Security in itself is not difficult to implement. If I want to secure a network, I just unplug all computers and bury them 10 feet underground. So that's not really the challenge. The challenge is to secure a network while allowing it to be used conveniently. So the big challenge is finding the good trade-off between security on one hand and usability on the other hand. And actually, that's why there's so little security. That's one of the reasons why there's so little security on the internet right now, is because people don't want to be bothered with the constraints of security. And so this trade-off is very difficult to find, and I'll propose a way that this trade-off may be optimized. Risk is also very transversal, it's very volatile, it suffers from a very strong propensity to increase with time, and security can be either reactive or proactive. If these theoretical aspects interest you, please come by the booth. I don't have time to address them thoroughly, but these are very important. Whenever you engage in a security process, it's extremely important to understand these. So before I move on and speak to you about clean internet, I just want to spend 5 minutes making a short demonstration to you. How is malware executed on your workstation? I said earlier that these are the kinds of attacks that one needs to fear right now, because they target Windows workstations, they give access directly to the internal network to sensitive data. These are the ones that are the most deadly right now. So such an attack, such a client-side attack, can target a bank or a SME or an individual. As background information, I introduced ethical hacking in Switzerland in 1998. And so I've been for many years selling to banks a service called ethical hacking, where they would pay us to hack their network and thereby allowing them to secure themselves. Using these kinds of techniques, over 150 banks audited, we never failed to access the core of the network using such techniques. So these techniques are extremely effective, whether they target an extremely well-protected organization or whether they target a residential individual. Obviously, the means and the sophistication can vary, but the principle, the underlying principle is the same. If we can switch the display, I'm going to show you two examples of an attack vector. The attack vector will be the technical component that will allow the hacker to execute software on your computer. Once this malicious software is executed on your computer, we can hijack your e-banking session, we can download your emails, download your files, access the rest of the network, access the banking mainframe, whatever. So I have several, and if you want to see all of them, please come our booth. I'm just going to show you the two most simplest ones. The first one is can be created by a 5-year-old child. It uses a feature of Microsoft Word called the OLE feature. So this is something quite effective even in most secured organizations because it relies on the human weakness. So you would typically receive a Word document like this by email. The email would encourage you to open the PDF document that is embedded in the Word document. People are not used to seeing PDF documents inside Word documents, but after all, what the heck, why not? So here is the icon. It looks like a PDF. It's called .pdf, so it must be a PDF. So I double-click on the PDF. There's a first warning. Approximately 95% of people click yes at this point. Have a second warning. Depending on the extension of the file here, people tend to be more careful right now, but you still have 1 out of 2 people who actually click on yes here, especially if the social engineering approach is well crafted. If I've been able to convince you that this is a legitimate piece of information, then you are more likely to click on execute. And once you click on execute, you've understood it's not a PDF document, it's actually malicious software. In this case, it's just burns the screen. In a real scenario, the malicious software would open a PDF and would start running in background, typically running a backdoor and allowing remote access to the computer. So this is extremely simple to put in place, no programming skills required whatsoever, just 3 clicks in Microsoft Word and you've embedded malware code inside a Word document. Last example is a bit more sophisticated and exploits a vulnerability in Internet Explorer. These vulnerabilities affect most client-side software, Adobe Acrobat Reader, Microsoft Office Word, here it's Internet Explorer. I would say that Internet Explorer is probably the most vulnerable one, so this is why the demonstration is more relevant. So same thing, you receive an email, there's either a link or an HTML file attached to the email. Here you see it's .htm. So if you open this with Internet Explorer, there's no warning because it's a file that is supposed to be safe. You see what just happened. I open HTML file, either by clicking on it or by browsing to it with my navigator, and this file is specially crafted so as to exploit a vulnerability inside the software, and so there is no warning, there is nothing whatsoever you can do. The malware will be executed, and this explains how even when people are careful, even when people are not executing attachments, when people are not browsing on dangerous websites, etc., they get malware on their computers. This is how this happens. These are the kinds of vectors that are being used. Client-side software vulnerabilities in Adobe, in Internet Explorer, in Outlook, in Microsoft Word, in Excel, etc. Okay, so these were very short examples. Switch. To show how easy it is to execute malicious software on a computer. So this is the first step: execute software on a user on the user network, on a workstation, and then communicate with the running software using a protocol that is authorized, typically HTTP or typically email. This bidirectional communication channel is usually quite easy to set up. Since people are authorized to communicate with the outside world, these channels can be used to encapsulate malicious traffic. So the particularities of such an attack are that human weakness is part of the vulnerability. The attack is carried out, is prepared offline. I mean, I write the malicious stuff offline, I prepare the vector offline. The attack is swift and sudden. It's difficult to mitigate and detect, and the impact can vary greatly. If it's an indiscriminate attack, it may be just spyware, which is basically harmless. If it's a targeted attack, its intent may be to hijack an e-banking session, for example. So why is there so little safety? Why in 2009 have we not come up with better solutions? And actually solutions exist. Technical solutions exist, organizational solutions exist. They are rarely implemented because these solutions are heterogeneous, are complex and costly. They're expensive to implement, and they're constraining for users whose liberty using the internet and whose usability of the computer is decreased. There is often technical bias. And because risk changes, evolves so fast, it's very difficult to keep up. So what are the trends today? And in the 5 minutes I have left, I'm going to speak about this and about clean internet. So clearly security is moving up the chain. Host-based security, having software in your workstation to protect you, has basically been commoditized inside operating systems. Microsoft announced last Tuesday that they were releasing a free antivirus downloadable freely for anyone who has a Microsoft Windows XP or Windows 7 or Windows 2000 license. So what they did with browsers and with media players, they are doing now with antivirus and host-based security. So clearly there's no more value here. The value is moving up the chain to the operator and to the ISP. That's actually why we are at Telecom. So ISPs, that's the first trend, security value moving up the chain. Second trend is that ISPs need to develop value-added services. Their revenues are shrinking because of IP convergence, because of Skype, because of changing environment, because of changing business. So this has been talked about thoroughly at Telecom here. ISPs need to develop value-added services. Security which is signature-based, which relies on a list of explicit threats that have been registered by humans beforehand, obviously is increasingly obsolete because there are so many threats, an average of 20,000 new malware codes per day in August 2009. It's impossible to keep up. And obviously insurance, these kinds of risks can be insured. This is another powerful trend. So how do we address these trends? ARIS builds and operates internet purification plants for operators and ISPs. We enable ISPs to deliver a clean internet utility. So the analogy with fresh water is especially relevant, because in early distribution phases of water, it carried along with it disease and risk. There are some countries in the world right now where you cannot drink water at the tap. There are no countries in the world, wherever they are, where you can drink the internet from the tap. You need to have downstream filters in order to use the internet conveniently. So imagine if, in order to enjoy fresh water at your home or your office, you needed half a dozen filters on each and every one of your taps: anti-chlorine, anti-phosphate, anti-pesticide, whatever else. It could work, but it would be costly and it would be constraining. So the same thing is true for the internet. You need now these half a dozen filters on each and every one of your taps, on each and every one of your computers. You need antivirus, you need anti-spam, you need a firewall, you need a content firewall, an IPS, IDS, etc. So this can work, but it's costly, it's constraining, and so it's not being used. So what we do is that we cleanse the internet upstream. We do this with the ISP, with the operator, and we have a very innovative technology to do this at a very large scale. And that's the main challenge, obviously. So what we do is that we combine two pieces of technology: deep packet inspection on one hand, and a security operation center on the other hand, that basically allow for this internet purification plant to function. So this has already been tested at a large national scale, and we are here at Telecom obviously to meet with operators, to meet with ISPs, and to explain to them how they can add value to their core business of providing raw broadband by basically enhancing it with a level of security. So all the functionalities that one would typically expect are included in the Clean Internet offering for the end user. If you're interested in going through this list, obviously I'd be more than happy to do it at our booth, which again is right here. So the unique selling propositions are quite clear. For the end user, cost reduction, because it's obviously cheaper to outsource this security provisioning to the operator than trying to do it by oneself in a downstream way. Simplicity, accessibility, and visibility. It's much more simple to call up your operator and to sell from now on, I want Clean Internet, and remove all of the downstream security, than to try to interoperate, integrate, implement, upgrade all this downstream security. And for the ISP, differentiation, new revenues, and reduced churn are the main benefits. So ARIS delivers Clean Internet as a managed security service. And I will conclude by presenting the latest innovation. We've presented our technology, our internet cleansing platform, to insurance companies, because we figure there is no reason why internet risk should rely on best efforts. I mean, you don't imagine a car manufacturer building cars that explode spontaneously on the motorway and then accepting no liability whatsoever. So the best effort era in IT security needs to be put to an end. So this is what we've done. We've basically asked insurance companies to audit our platform, to assess our capacity to reduce risk, which they have done in such a way that we are now able to package together with a technical protection, a financial protection. In the same way a smoke detector that is vetted by insurance companies allows you to have a fire insurance at a fraction of what it would cost otherwise, in the same way Clean Internet subscribers can cover their internet risk thanks to the packaged insurance policy that we allow them to subscribe to. So that's it for the presentation. We have 3 minutes for questions and the whole day at the booth. I would say that as a conclusion, IT threats are evolving and adapting extremely fast. So the current paradigm is not satisfactory in fighting them. So this paradigm is evolving. ARIS is not creating this trend of Clean Internet. This trend is imposing itself. The only merit ARIS has is to have been able to identify it early enough so that now we have a powerful platform we're able to present here at Telecom. But people are increasingly going to expect their ISP, their operators, to deliver them with a Clean Internet utility. And these trends are obviously converging in this direction. Thank you for your attention, and I'm open for questions.